Today we're going to talk about complex numbers. This should be a little bit of a review from Algebra 2. This first slide is not on it's not in your packet, and if this is a little cut off, it says the imaginary number I. I is the imaginary number. It represents the square root of -1. Anytime you see I, it's the same as the square root of -1. Anytime you see the square root of -1, you can replace it with I. Now, if we take I equals the square root of -1, you don't need to write this down if you don't want to. If we were to square both sides, on the left we have I squared. On the right, what is the square root of -1 squared? The square root and the square will cancel each other out, leaving you with simply -1. So there's two things that you need to memorize. The first thing is I equals the square root of -1. The other thing that you need to memorize is that I squared is -1. All right, let's try a few problems. The first one, the square root of -9. We could take the square root of -9 and split it into the square root of -1 times the square root of +9. The square root of -1 is the imaginary number I. What is the square root of 9? 3. So this first term is 3I. You always want to write the whole numbers first and then the I. And then if there was anything left under the radical, you'd write that at the end. The shortcut is when you see a negative inside a square root, you know immediately that you've got I times that radical. What is the square root of 49? 7. So this is 7I. And now you can combine like terms. 3I plus 7I, 10I. Okay, square root of -50. You know that there's an I because of the negative under the radical. So this is I times the square root of 50. Can we split up the square root of 50? Using what? 25 and 2. The square root of 25 is 5. So I've got I, I've got 5, and I've got a square root of 2. The correct way to write all of that is 5I square root of 2. Write the whole number piece that's not under a radical. Then write the I, and then finally finish off with whatever is under the radical. All right, then this problem says minus. And now let's do the same thing with the square root of -8. We've got I. How can we split up the square root of 8? Square root of 4, square root of 2. So the square root of 4 is 2. We've got the I. And we've got a square root of 2. So minus 2I square root of 2. In the beginning part of chapter 9, we talked about like radicals. You can add and subtract like radicals. Do you see how this is 5 times stuff minus 2 times the same stuff? Because I square root of 2 matches I square root of 2, we can do 5 minus 2, which is 3 times I square root of 2. Okay, we've got square root of -6 times the square root of -6. The square root of -6, because there's a negative, you know there's an I, so it is I times the square root of 6. Can we split up the square root of 6 at all? No. There's no perfect squares smaller than 6 that would help us. So we've got I square root of 6 times I square root of 6. Both of these are I square root of 6. Now let's multiply. In here we've got I times I. I times I is I squared. And what's the square root of 6 times the square root of 6? The square root of 36, which would be 6. Okay, what did we learn on the previous slide? What does I squared equal? -1. So this is -1 times 6. So our final answer right here is -6. It's a big long string of work. Okay, this is saying when they ask you to write a complex number in standard form, they want the real part first and the imaginary part second. For example, and you don't need to write this down, if you've got 2 plus 3i, that is a complex number written in standard form. If you were to see 5i minus 7, that is not standard form. You would need to rewrite that as -7 plus 5i. That would be correct standard form. So they want the real stuff first, the I stuff second. All right, example 2. Perform the operation and write the result. This is adding and subtracting with complex numbers. Basically, whatever symbol you see in the middle, just use that symbol each time. You're basically matching up like terms. What does 4 match up with in the other set of parentheses? 1. Use the plus sign. 4 plus 1 is 5. So the first part of our answer is 5. Now, what does 7i match up with in the other set of parentheses? -6i. So do 7i plus -6i. 7 plus -6 is 1i. In B, you're going to do exactly the same thing, but you're going to use subtraction both times. So 1 minus 3, what is 1 minus 3? And then -8i minus 12i. -8 minus 12, -20i. So you're matching up here. It's like terms. And I suppose I should, how can I do this? I don't even know. There. Those are like terms. And these are like terms. You just have to use subtraction both times. That's just, you know. All right, well, here, this one, minus sign, this one, 1 minus 3, this one, plus sign, that one, yeah. Okay, in example C, I would strongly recommend that you take this negative and distribute it into the parentheses. So this is 18 minus 5 minus 2i minus 16i. And you could really do that in B as well. You could distribute the negative and then combine the like terms, whatever you wanted to do to make that make sense in your brain. 18 minus 5 is 13. -2i minus 16i is -18i. Okay, easy peasy. Don't laugh too much at my attempts to whatever. Yeah. Multiplying complex numbers. Distributive property, or in example B, double distributive property. We need to distribute -5i to the 2 and to the 7i. So -5i times 2, any guesses? -10i. And then -5i times 7i would be -35i squared. You multiply the -5 and the 7 together, and then I times I is I squared. Okay, what did we talk about at the beginning of this lesson with I squared?
What's the question?
I is the square root of -1. That's one thing that you need to memorize. The other thing that you need to memorize is that I squared is -1. These are two important pieces of information that you need to get committed to your memory. Anytime that you see an I squared, this is really -35 times -1. What is -35 times -1?
35.
Positive 35. So we have positive 35 and we have -10i. We need to write our answer in standard form. So 35 comes first and then minus 10i. On B, I want you to double distribute. So distribute the 3 and then distribute the 2i. You're going to end up with 4 terms, and then we'll talk about combining like terms. Pause the video if you're watching, try example B, and then play the video and we'll talk through it. Okay, when you double distribute, you should get these 4 terms. If you didn't, look back at my color coding to see what was multiplied times what and what you should have gotten. These are the correct 4 terms. Now let's talk about combining like terms. The first thing I see is that in the middle we have -15i and 8i. Those will combine to give us -7i. Quit it. So we have 12, -7i, and -10i squared. But what do you know about I squared?
Negative.
I squared is -1. So this term is really -10 times -1, which means it's +10. So you have +10 and +12, which is 22. And you want to write the 22 in front because that's the real part, and the -7i is the imaginary part. So our final answer is 22 minus 7i. Okay. Here's your assignment for the first day of 9-6. I'm going to give you a quick preview. Tomorrow we are going to do example 4 and example 5, and you'll have a second book assignment. Okay.